In this example, we have a little bit more to do before we can just jump into what the word says here, or. So remember, in the last example, we saw or, and that meant union. So that means put everything together. But before we can do that, we have to solve each of these smaller inequalities. So here, we just need to subtract 6 on both sides, which means x is still greater than or equal to, and this is 4. Over here, we need to divide both sides by -2. Since we're dividing by negative, that means we have to change the direction of the inequality, so this becomes greater than -7. Alright, so we solved each of these smaller inequalities, and now we're going to put these together on the same number line. Remember, that's what we can do with union. We're not looking at where they intersect, we just put it all together. Alright, so paying attention to the order here, we've got -7 on the left, 4 on the right. Notice that I'm not wasting time doing a bunch of tick marks counting between -7 and 4. I also don't need to mark where 0 is. It's not really that important to me. So greater than or equal to 4 is closed at 4 and going to the right, forever and ever, like that. This one, once we divide it by the negative, now turns this into greater. So greater than -7 is open at -7 and going all the way to the right. Remember that union says put everything together. In the last example, they were going in opposite directions, so I had to use the union sign to join them up. But here, they're not going in opposite directions. I just have to describe what's being colored on this number line. So we see it's starting from -7, and it goes all the way to the right toward infinity. And you might say, what about the 4? Aren't you stopping at 4? I'm not. Because this one right here that says x is greater than -7 goes greater than -7, and it keeps on going and going. What is actually happening is that the solution set here is a small subset of the larger one formed from x is greater than -7. So we say from -7 to infinity, and that's it. Now, on a little side note here, if instead it had said x is greater than or equal to 4 and x is greater than -7, would that have made a difference? Well, since that's and, we'd be looking for the intersection. And if we're looking for the intersection, we would have actually taken time to graph these guys above, not on the number line just yet. So that would mean greater than or equal to 4 and greater than -7. And then I would have said, okay, where's the intersection? Because that's what the word and says. So remember, and means intersection. And here the intersection happens over there. So what happens to the right of 4, and notice that 4 is included for both of these, so this guy would then be filled in. So your intersection would be from bracket 4 to infinity. The direction is very important here. Also knowing whether it's and versus or. Totally different if I'm dealing with a union versus an intersection. Now, this problem that snuck in at the bottom of the page is an interesting guy. So what we have now are what we call 3-part inequalities. And when you look at these 3-part inequalities from left to right, the flow has to be the same. You can't ever go less than, greater than. Those are in opposition. They have to flow in the same direction. Both less than or both greater than. So these guys are both less than. And we're just describing ordering between 3 different things. The -7 is less than some number, which would then be less than 2. There's an easy way and a hard way to do this. The hard way is to actually break this up and say that this is x is less than or equal to 2. And the other part here that says x is greater than or equal to -7. So it's really an understood intersection. We don't say the word and, but it's understood to mean that. So you can do this. and you can see where the intersection is, but really the easier way to do this is to go straight to the number line. Negative 7 and 2. Notice x is literally in between negative 7 and 2. And so that's what we say. We say that it's between negative 7 and 2, including negative 7 and including 2. That's really all we have to do for a problem like this. And then we describe this using interval notation. So bracket, negative 7 to 2, with a bracket. And that's it. Now, in the next video, we're going to see these three-part inequalities. They'll get a little bit more complicated, so it just takes a few more steps to solve them. But once you get x by itself here right in the middle, you can go straight to the inequality, which leads you straight to the interval notation.